This is Euclid Book 6, proposition number 18, and boy, what a challenge this one was. On a given straight line to describe a rectilineal figure similar and similarly situated to a given rectilineal figure. Okay, we're going to start out with the straight line. AB is the straight line. Here it is. AB is the straight line. Okay. And CE, the given rectilineal figure. Alright, so the rectilineal figure is actually going to be CED. Okay, actually it's going to be CFED. It's weird. Just go with it. Okay. Eventually it's going to be a rectilineal figure. Alright. And if you want to do it in a funky different way, you go right ahead. I just decided to do it this way, mainly because I figured it would be a lot easier for you to see it this way. Okay. Thus, it is required to describe on the straight line AB a rectilinear figure similar and similarly situated to the rectilinear CE. So what you're supposed to do is you construct on here a rectilinear figure similar to this one here. Okay, let DF be joined. Alright. Let DF be joined. There it is. And on the straight line AB and at points A and B on it, let the angle GAB be constructed equal to the angle of C. Okay. GAB. This angle right here is equal to the angle of C, which is right here. And the angle ABG, like this, equal to CDF. Now, how are you going to construct on this line right here these two angles right here? Well, the way you're going to do it is by Euclid Book 1, proposition number 23. Okay, so these two angles right here, when you get finished, will be these two angles right here. There, and of course, this is proven by Euclid Book 1, 23. Therefore, the remaining angle CFD, this one right here, is equal to the angle AGB, and this is by Euclid Book 1, proposition number 32. Therefore, the triangle FCD, this triangle right here, is equal angular with triangle GAB, right there. Therefore, proportionally, as FD, well, here's FD, as FD, which is right here, is to GB, okay, so as FC to GA, FC, GA, see, FC right here, GA right here, and CD to AB, CD, AB. So far, so good. Alright. Now, we have already drawn this part for the next part of the proof. Now we're going to duplicate this over here. Again, on the straight line BG. Well, here's the straight line BG. And at points BG on it, let angle BGH. Okay. Well, here's BGH, okay, be constructed equal to the angle DFE. Okay, BGH is equal to angle DFE, this one right here. Alright. And the angle GBH, this one right here, is equal to the angle FDE. This one right here. Therefore, the remaining angle at E is equal to the remaining angle at H. E, right here, H, right here. They're equal. And we can prove this by Euclid Book 1, propositions number 23 and 32. Therefore, the triangle FDE, this one right here, this triangle right here, is equal angular to rectangle, is equal angular to with the triangle GBH. Well, here is GBH. This one right here. This triangle is equal angular to this triangle right here. Therefore, proportionally, as FD is to GB, as FD is to GB, so as FE to GH, FE way up here, GH way down here, and ED to HB. ED, HB. Perfect. Okay. But it was also proved that as FD is to GB, FD to GB, so is FC to GA, FC, GA, okay, and CD to AB, CD, AB. Therefore, also, as FC is to AG, as FC is to AG, so is CD to AB, CD, AB, and FE to GH, FE, GH, and further ED to HB, ED, HB, and since angle CFD is equal to angle AGB, CFD, this one right here, and AGB, AGB, this one right here. And the angle at DFE, well, where's DFE? DFE, this one right here, is equal to the angle BGH, BGH, this one right here. Therefore, the whole angle CFE, CFE, this one right here, this whole thing, is equal to the whole angle AGH, AGH, this whole thing right here. For the same reason, the angle at CDE, CDE, this one right here, is equal to angle ABH, ABH, this one right here. This whole thing here, and this whole thing here are equal. And the angle at C is equal to the angle at A. C is equal to A. And the angle at E is equal to the angle of H. E, H. Therefore, AH is equal to equal angular with CE. So the whole figure ABHG, this whole figure right here, is equal angular to CDEF, this one right here. And they have the sides about their equal angles proportional, therefore the rectilineal figure AH is similar to the rectilineal figure CE. This is by Euclid Book 6, definition number 1. Therefore, on the given straight line AB, the rectilineal figure AH has been described similar and similarly situated to the given rectilineal figure ECE, which is what we were trying to prove. Alright, if you have any questions, leave them down in the comments below. I know these are not exactly the kind of figures you were looking for. You can see these also on the internet. You can just go ahead and take a look at this. Or you can get the Euclid proofs for yourself. You can buy them at the bookstore. I don't care. Anyway, if you have any questions, leave them in the comments below. I will tell you more in a future video, so stay tuned.